G'day guys, how's it going? So in this video, we're going to continue learning more about references and borrowing in Rust. And more specifically, we're going to look at mutable references and something called dangling references. And basically, we're going to look at the rules that govern both of those things. So in the previous video, we looked at a very simple example where we passed in a reference of a string that was stored in main to a function, and we read the value of that string out, okay? And the understanding of that was we weren't making a copy of the data, nor were we moving the ownership, right? We were just borrowing temporarily in the function. Now, the first example I want to show you is that we can do this even with just variables in the same function. So I can do something like this where I can go let s1 and make it equal to the string hello, like so. And then I can say let s2 and make that equal to a reference to s1. And I can also do the same with, say, another variable, say s3, and set that to a reference of s1 as well. And then we can print all three of these out, right? So I can say s1 is s1, s2 and s3, right? So this is a really simple example just to illustrate that variables work as well when they're in the same function, right? So there you go. S1, S2, and S3 all point to the same thing in the heap memory, so therefore it prints out hello. Cool. Simple little cheap example there, but I just wanted to get it out of the way. Now, I'll keep hold of S1 for a second. Now, what I didn't show you in the previous video was how to make changes to this hello value based on the fact that S1 owns it, right? We've shown you about how to move something and then you can change the value, or you can copy it and you can change that copied value, but I didn't show you how you could change the value of this string based on only having a reference. So for example, if I was to do something like this, where I can go, say, function update text, like so, and we'll go some text, and for now, we'll just say it points to a reference of string, right? And then in this piece of code, we do something like some text dot push string, and I'll just add world like that on the end of it, right? So if I do this and I save it, it's going to tell me that I can't do this because it's behind a at reference and the data is being copied, but it needs to be what we call a mutable reference. Therefore, it needs this prefix of mute, right? So what that's really saying is we need to make this variable here not just a reference to a string, but a mutable reference to a string. And how we do that is just after the little ampersand, we type the word mute and then add a space. And now that is a mutable reference. So now the error will go away, right? So now we're able to make changes to this mutable reference. Now, how we pass it in is also similar. So we don't go like we were before and go update text and go just the address of S1. Right? If we do this, this will also not work because it is possible in Rust to pass just a regular immutable reference where we just have an ampersand, or a mutable reference where we do it like that, right? So we have to give it what it wants, like so. And now, I'm not sure why it's failing here. Oh, it's failing because I didn't make that mutable. You must make the original owner mutable, and then it will work. But yeah, now we have a mutable reference to S1. So S1's still the owner. That works the same as any other reference we saw in the previous video. But now this is one that we can actually change in a function, right? So let's just print that out. So we'll just go print, right, text, and I'm going to pass in a reference to S1 this time, like so. And we're going to create another function just here that goes print text, and we're going to do similar to above. And this time we're just going to use a regular immutable reference to string, like so. And then we're just going to print out, some text is, and then we just go some text. Cool. So let's make sure this code works. So we'll just run the main. And there we go. Some text is hello, comma world. So what have we done here? We first created a mutable string called S1, which is the owner. The owner then gave a mutable reference to update text, which is derived by this argument up here saying I need a mutable reference in order to do what I need to do here, which is push the last piece of comma world onto the string that you give me. Then it comes out and goes, okay, now I'm going to print what you just did, but I don't need a mutable reference. I just need a regular reference. So in that situation, we use the at in front of the string again, like we saw in the previous video, and we can read it out. Cool. So that's another example of properly using references in Rust. Now, up to this point, everything's been nice and clean and everything, and we'll go through one more example as well of a clean solution. So let's get rid of the functions. We'll come back to our S1 and we'll get rid of those two function calls. And now what we'll do is we'll use variables in a similar fashion. So let S2, and we'll make that equal to a mutable reference to S1. And then in line, I can do something like this, S2.push string, whoops. And we can say, comma, let's say in this case, test, right, just to be different. And then just for the moment, I'm going to print out, well, we can print out both S1. S1 is S1, and S2 is S2. All right. And if you haven't worked it out, it's going to tell me there's an error here. So it's saying essentially that I cannot borrow S1, right? Or I can't use S1 here because I already borrowed it as an immutable reference here. Now, what does that mean? Well, essentially what it means is when we have an immutable reference to something, as long as it's in the same scope, right? So at the moment, we're in this, sorry, not same scope, same block. As long as we're in the same block, we must read from the mutable reference first before we can read from anything else, including the owner. So if I swap these around and save and run, you'll see it passes. Cool. So that's just a little distinction there. So the thing to understand is for a mutable reference, one of the rules is if you're going to use a mutable reference, you cannot refer to the original owner. You cannot read from the original owner until you've written to that mutable reference. Okay. Now, similar to this, it's the same as if I tried to do something like this. To say we keep S1 there, and then I say straight after this, I want a reference, a regular reference to S1 by saying at S3, at S1 like that, right? And then it's going to tell me I can't do that because I've already issued a mutable reference before it. So you can't reference any other references until such a time that you have read from such reference. So now it'll be okay down here, right? But if I push it past or before the print line, it's going to throw an error. So basically what Rust is trying to do by enforcing this rule of you must read directly from the immutable reference after writing to it, and you can't read anywhere else, right, is to prevent a situation which we will see later on, which is a race condition. So when we get into threading, there are going to be given situations where we can create references to things, and it can be on a different thread. And if we have a situation where we're trying to read from a reference before some other thread's trying to write to it, Rust is going to say, you can't do that. And this is a very simple example of that, but it's just something to understand early. If you're going to create a mutable reference, you must do something with it and then read from it before you can do anything else. right? So in this case, now I can, down here once again, go S3 is S3. And this works as it did before. All right, so if I run it now, it's now going to pass as usual. Cool. Compiler's happy. Everything executes the same. Now, what else? What you also can't do is you can't create two mutable references to the same thing. So, for example, if I get rid of the S3 from down here, so we'll just get rid of that code for a second, and say straight under S2, I try to create another mutable reference equals mute S1, right? It's going to complain again. And that is because a similar thing to what I just mentioned, the whole threading situation, right? We don't want to have two potential variables that can write to the same piece in memory at different times, and therefore we have race conditions, right? So the same as reading from it, we don't want to read too soon because it may not be written to yet. We also don't want to write at different times either. So the rule with Rust is you can only ever have one mutable reference at a given time. Now, once I've read from S2, I can once again, like before, create another mutable reference to S1, right? And this will be fine. And then in this given situation, I can do something similar to up here. And I can say, let's say test2 and make that S3. And then I can print out, again, I have to follow the rules. I've got to put S3 first. So I've got to read from S3 before I can read from S1. And if I save that and I run it, now you're going to see something weird where it says S2 is hello test, but then S3 is called hello test, which is what S2 was pushing into. And then it also appends test2 after that. So now S1 at the end of the program is going to have both S2 and S3 added to it, as well as S3 is going to also have what S2 did plus what it did to itself. Cool. So a little confusing. It's very hard to work out when you're first learning Rust, all of these rules, but they are there for a reason, right? So just understand one mutable reference at a time. That immutable reference must write and read before you can create another mutable reference or another reference in general, or even when you're trying to read directly from the owner. Okay? Very confusing. Now, there is an exception to this. So I said everything has to be in the one block for that to be a problem. If I give you an example of what it would look like if I used a block instead, so let's just go back to square one here, and I added a block. I don't know why it didn't add the indentation, but anyway. Oops. So if I down here decide to go let S3 and have it equal to a mutable reference of S1, and then it goes, cool, let's go S3 dot push string, and we'll say, oops, we're not going to say string, let's say comma world. All right, and then we try to read from that. So in this case, I'll just print out S3 for now. Is S3. Obviously, this is still going to work because there's really no difference. You're just executing inside of a block. But what I can also do straight after it is I can go let S2, which is also, and we can make this, S2, make that also a mutable reference to S1. And I can do exactly the same thing I did up here, right? I can say S2 dot push. Now let's say we push a dot. Right, and then straight after that, I can go print line S2. And then ultimately we'll print line S1, right? And we'll see what we get. So will this program work? Well, keep in mind, we've got an S3 declared up here, but we've also got an S3 declared down here, right? Even if I take away this print line, just to take away that read option, right? Will this code still run? The answer is it does, right? And the reason why it does is even though I never read from S3 here, which we had to do before we could access it, S2, right? Because it's inside of a block, once this block is ending, S3 is deemed no longer available. Therefore, the reference is destroyed. Therefore, there is no mutable reference, which means by the time it gets to S2 and it tries to create a mutable reference, it's the first mutable reference in the code again. So that is why this is allowed. Cool. So that's that example. What else is there? The last one we need to talk about that I thought was of interest is something called a dangling reference. So let's say, for example, we have a function and we wanted to get the value of a function and we didn't know much about Rust. So we did something like this, say function dangle, and we said we're going to return, we're going to return a reference to a string. Okay, this is what we're going to do. If we try to do something like this, where we go, I don't know, let s equals string from returned value, and then we just try to return s, which is a reference. Sorry, it's not a reference, it's the original value. Now we try to return a reference instead, right? And then in our code down here, let's say we'll get rid of that block. And we'll even get rid of this block for now. And we'll just make S1 equal the call to dangle, right? So we'll just call dangle. And then let's just read S1, right? So we're getting a reference from a function, essentially. That's what we're trying to do here. So will this work? The answer is no, it will not. It will throw a compiler error. And the reason why it's throwing a compiler error is pretty straightforward. The lifetime of S is for the lifetime of this dangle function. So if I try to return a reference, by the time that reference gets back to the caller, the original owner is gone, right? This is what is called a dangling reference. Now, in some programming languages, this would be allowed, right? But Rust is smart enough to say, you're trying to do something that you shouldn't be doing at all. You're trying to refer to something that no longer exists because we have that ownership in place. The ownership of this variable disappears when the life of this variable disappears, which is at the end of this call. Well, this is the end of the call here, right? So S1 is not going to point to anything. So rather than creating confusion for programmers, it just throws a compiler error and says, nah, you're not supposed to do this. So that is what is called a dangling reference, right? So if you ever try to do something like this, don't do it. Obviously, the solution to this is don't use references, just return the actual object itself, right? And then this will compile. And it's totally fine because it's issued, in this situation, a move out to here. So moves are very handy when you're returning from somewhere. But references are really good when you're passing things inside of other things. So that's how I usually use it. So if I'm passing a parameter to a string, I'll use a reference. If I'm returning a value that's a string, I'll return the actual value because it's going to be destroyed anyway. So I might as well move it, right? And that's it. That's all I've got for this video. So the next video, we're going to start looking at strings a little more. And then after that, we'll start looking at slices. So see you all then.